everyone, my name is Koi. Today I am here to present my research on the analytical lab with title of the machine learning based analysis of the global GDP direction towards the US interest rate shift. And I would like to express my thankful and I appreciate to Dr. Ng along his guidance on my research project. So you can refer to the slide. This is the summary contents with I included in this presentation, which is the background of the study, problem statement, research objective, research question, and the scope of the study. And also I have a summarize of the literature review I using in the research project, and methodology, result, and the conclusion, and also the limitation on recommendation. So for the background of the study, I'm using the founder style showing in the slide to describe a bit for the background of the study. So as we know that actually US have the global influence, with US have the largest economy, and with play is the current dominant capital market. So when the US interest rate increase, so you're bringing a spillover effect, which is a title of the global financial condition and slow down the global GDP. So when the rate is increased, meaning that the borrowing cost for the other countries is increased, so you're bringing an effect which is the consumption and the investment decrease. This meaning that the capital outflow from the emerging market will be increased and causing a liquidity squeeze abroad. So when this condition is happening, the dollar appreciation will happen. When the dollar appreciation happening, this will weaken our export, heavy of the debt, abundant for the dollar dominant loan. So in this research, we aim to build a machine learning tools to better identify how the US rate impact on the global GDP and provide a practical insight for the policy and the strategy. So let's continue with the problem statement why we choose the machine learning model instead of the traditional economic model. So as we know that actually the traditional model is bringing many limitations such as the rigid assumption. So the traditional model is keeping assumed stable and a linear relationship. And actually this traditional model is very poor on the real-time adaptability, and they are unable to reflect the country-specific vulnerability and causing the inaccurate policy and the market judgment. And for the grouping, actually the traditional model compared with the machine learning model, they are oversimplified grouping with using the regional aggregation ignore key difference. So besides, actually, the traditional model has a gap in the usability. They didn't have the unified framework in balancing and the predictive accuracy and interpretability. So from that, the strategic decision of the traditional model may suffer from the mid-align model, with causing the inaccuracy output and also the market judgment. So let's continue with the research objective. So the first one actually is to identify the sensitivity of the global GDP to the US interest rate changes using the machine learning technique. The second one is to evaluate and compare the predictive performance between the white box and the black box model algorithm using the key metric. So the next one is to validate the robustness of the developed model across the global with the varying of the finance openness and the intuition capacity, and also the less resilient to the external shock. And last is to develop the optimized algorithm to analyze the sensitivity of the global GDP to the US interest rate shift. So in this slide, you can see the 4 research questions we're using for the research objective. First is the how sensitive is the global GDP growth to changes in the US interest rate. Second one is the how do the individual machine learning model for the white box and the black box used in the performing the prediction of the GDP sensitivity to the US rate. And third one actually is how robustness as the general of the developed machine learning model when validating across the global with the multi-country with the varying of the economic structure and the stability. And the last one actually is the how do the optimized previous model compare the accuracy and the robustness to assemble in the machine learning method. So let us have the further study on the scope of the study, which is bringing the contribution for the economic practical, migrate the risk, and also bringing the benefit to the economic ranking system. First, this study actually is expand the machine learning application by integrate the interpretive with the predictive performance, and also provided the structural tool and insights useful for the investment firm, policymaker, and also the multinational corporation, and also help the stockholder anticipate on the opportunity and reduce the economic risk from the US monetary policy. And the next one actually is the support and improve the forecasting, comparative analysis, and give a benefit to the long-term strategic planning for the future research. So this slide is showing the summary of the literature review. I'm using the article in this study. So I actually is separate in the few sections to discuss this. The first one actually is the US monetary policy and the global economic spillover. And the key focus for this section actually is to identify the spillover effect on the US interest rate changes on the global economic, such as the financial needs and also the investments and the output. And the second one section is the impact of the interest rate shift on the global GDP dynamic, with the key focus on the GDP response to the US monetary policy tightening. And in this section, we will discuss about the track structure, how the complex and the non-linear GDP respond to the required flexible tool, like the machine learning tools. And the next one actually is the image of the machine learning in the macroeconomics. We focus on to identify the role of the machine learning model and also compare with the traditional model. So the next section is the white box machine learning model in the economic modeling. So we focus on the interpretability and the theoretical consistent. And we meant to explore more in the limitation, which is how the struggle with the non-linear dynamic system risk and instability in the panel data. And the next section is the black box machine learning model for GDP and financial prediction. And key focus on the predictive accuracy in the non-linear setting, which we can identify the challenges and also the how to improve the future study. And the last but not least is the fake effect and the endogeneity treatment using in this study. So as we know that actually the fake effect and also the endogeneity treatment is bringing economic with the machine learning flexibility. So we will identify and get the previous study to identify how the fake effect is controlling the country heterogeneity which we using in this study, and how to avoid the spiral correlationship, and also the lag structure, capture the dynamic complex, and also how the endogeneity to improve the cultural identification and mitigate the bias. So this slide is showing for the infographic information for the methodology, and the first one actually is the data collection. I've collected the data from the World Development Indicator and also the Federal Reserve Economic Data from the years 2005 until the 2025, totally with a range around the 20 years data set, with including the macroeconomic indicator and also the US Federal Fund Rate. So after we get the data, we go in for the data cleaning. We clean the both data set and also impute the missing value using the global mean. After that, we merge the data set. After the merge data set is the getting, we go in for the model specific, which is the country fixed rate fixed effect. We use to control the unobserved heterogeneity and also implement the black structure. This is M to capture the dynamic resistance. And also the endogeneity treatment to address the bias with the variable and also the imputation. We're using the random data split ratio of the 80%, 80 and 20, meaning the 80% for the trend set and 20% for the test set. This is to prevent the overfitting and also ensure the general stability. For the feature definition, which is the dependent is referred to the GDP growth for the non-US country, and also independent is variable is referred to the 7 macro indicators showing in the dataset, including the fund rate. So in this machine learning model, we're using two techniques, which is the white box and the black box. So the model in the white box actually is the rate regression, ratio regression, elastic net, and for the black box is the random forest, gradient boosting, and also the active boosting. So in the iteration metric, we are using the R square to expand the exponential power, and also the mean square error to analyze the larger error, and also the mean absolute error to robust the outlier. For the robustness check, we are applying for the careful cross validation. So this slide is showing the result for the model performance result with the summary table for the both 3 metric and also the bar chart to compare the model performance across the 6 models. So let us continue to discuss the decision after we get the result. So based on the summary and the bar chart is showing that the gradient boosting achieved the highest R square and also the lowest RMSE, which indicated the strong exponential power and the predicted accuracy. So, and actually the crossover data is owing for to the black box technique, which is the active boost and the random forest. Both of the model actually is also performed well, but they get a slight lower of the R square and competitive mean absolute error value compared to the gradient boosting. So, however, for the white box model is showing very fit in the performance with the R square is lower and lower than 0.12. So, this is suggesting the limitation of capturing the non-linear dynamic. So, as a conclusion for the model evaluation using these 3 metrics is 3 best example models are more effective to capture and modeling the GDP response to the US interest rate and balancing the accuracy and the robustness compared to the linear model. So this slide is showing the robustness analysis using the K-cross validation. So this slide actually is showing the summary of the cross validation performance result. And the slide has been showing the model performance for the K-cross validation across the 6 models. So for the robustness analysis, which is the careful validation summary result, is showing all model actually is underperformed with the negative square R value. For the white box model actually is showing the better error control compared with the black box, but they still showing the big exponential power. For black box, they're showing the less accurate prediction and also the greater variance showing the unstable across the cross validation. In conclusion, showing is white box model show the lower error metric, but none of the model actually is a generalized build. That means that this is highlighting the need for the further tuning, feature engineering, and also offer the alternate modeling strategy to improve the robustness. So in the conclusion, the single run result is showing gradient boosting is the best performed model, and following by the active boost and the random forest. Active boost and random forest consider the following best model because they're able to capturing the non-linear dynamic compared to the white box model, which is the rate ratio elastic net, which is representative of the linear model. For the cross validation result, is showing all model is underperformed with the negative of the square R value, is showing the poor generalization on the unseen data. However, the white box model still have relative the better error control, and black box model is unstable with the higher variance and less reliable across the fold. So in the conclusion, this is indicate this study is a need the further tuning, feature engineering, and alternate approaches to achieve the reliable forecasting. So let us continue with the limitation and the recommendation for the future study. So the first of the limitation in this study actually is the random data splitting. Actually, this method is not suitable for the time series forecasting because this is have a risk of the data leaking causing the inaccurate prediction. And the second one is the cross-country heterogeneity. So as we know, actually the different economic structure will causing the bias towards the largest economy. So less of the country certification will reduce the generability. And this study actually has the overfitting risk because the random forest and the gradient boosting showing the instability across the fault and also limited the robustness analysis and the generalization. So in this study, I only able to implement the single leg variable, we only able to capture the short-term dynamic and unable to reflect the long-term temporal relationship compared to the multi-leg variable. So in this study, for the recommendation for the future research should be prioritize the chronological split with the most suitable for the time series forecasting and also the improve the robustness tuning and the model averaging and implement the multi-leg structure compared to the single variable to strengthen the predictive accuracy and provide the more reliability in the GDP sensitive analysis. That's all for my presentation regarding the machine learning based analysis on the global GDP sensitive toward the US interest rate changes.